right, today we're going to be learning how to complete the square. I would say that most people consider this a relatively challenging topic, but there are problems with various degrees of difficulty, so let's get started. We're going to look at a few pre-examples first. I'm going to show them all at once, and then we'll see how you do. But you need to make sure you know how to do these in order to do the problems. So if I was saying solve x squared equals 32, I need you to make sure that you know that you are going to solve this by taking the square root of both sides to solve for x. So remember, the square root of x squared is the absolute value of x. So the absolute value of x equals square root of 32. Therefore, x must equal plus or minus square root of 32. And hopefully you remember from an earlier chapter when we're simplifying radicals, that's 16 times 2, square root of 16 times square root of 2. So we would probably say x equals plus or minus 4 root 2 would be a good official answer. If I tried the second one, okay, solve the quantity x plus 8 squared equals 9. So again, I would solve this by taking the square roots because that squared term's already by itself. So now the square root of x plus 8 squared, that's the absolute value of x plus 8 equals 3. Okay. Therefore, x plus 8 must equal 3 or negative 3. So I would write maybe just negative 3 equals x plus 8 would be easier to solve. And then just solve that by subtracting 8 from both sides. We think x equals negative 5. Or, if I subtract 8 here, x equals negative 11. And if I check those back in here, negative 5 plus 8, that's 3, so 3 squared is 9, so that would have worked. And the first one, other one, negative 11 plus 8 is negative 3, and negative 3 squared also equals 9, so they're both good answers. Okay. This last one. If I try solving here, if I take the square root of both sides, the absolute value of x minus 3 equals, square root of negative 25. I cannot do that at this stage in my math career, so that's not a real x, but we're going to say there's no solution here. Okay, so we're going to try to get problems to look like this so we can solve them. All right, here's the general rule. You can solve an equation in which one side is a perfect square trinomial by taking the square root of each side. So we have this problem, solve for the variable. X squared plus 10x plus 25 equals 49. What I hope you notice is that this has a nice, beautiful pattern. X squared plus 10x plus 25, that's x plus 5, the quantity, squared. That's a bad 2. That's x plus 5, the quantity squared. So we know that x plus 5 squared equals 49. So if I'm going to solve this, again, I'm going to take the square root of both sides. I get the absolute value of x plus 5 equals 7. Therefore, x plus 5 must equal 7, or x plus 5 could equal negative 7. Solving each one out, here we get x equals 2, and here we get x equals negative 12. Okay, and you would check those to see if they're right, but we're definitely going to run out of time if I check everything. All right. So right here, a squared minus 12x plus 36 equals 9. Try to do this on your own if you can. All right, so again, you're going to notice that's a perfect square. That's a minus 6, the quantity squared, equals 9. So to solve that, I would take the square root of both sides. I'm going to get the absolute value of a minus 6 equals 3. Therefore, a minus 6 must equal 3, or a minus 6 could equal negative 3. Solving both, I'd get a equals 9, or a equals 3. And those would be my two answers. Okay, here's where it's going to get more challenging. We are going to actually work on completing the square. When we're completing a square, we are going to go through the process of finding the last term of a perfect square trinomial. So we're going to try to make something that's not a perfect square trinomial into a perfect square trinomial. So right here, it would be x squared plus 2x plus what would actually be a perfect square. What I hope that you notice, okay, when you're doing that, it's going to be x plus something times x plus that same thing. When we get that middle term, we're adding these two things up. Okay, so to get two terms that add up to 2x, each of them has to be 1x, right? If they're the same. So this is going to have to be x plus 1 times x plus 1 to get that middle term of 2x if it's a perfect square. Therefore, my last term, that's going to be found by that. It's going to be plus 1. So x squared plus 2x plus 1, that's a perfect square. That's going to be x plus 1, the quantity squared. Okay, and I hope you're going to be noticing some patterns that happen here. X squared plus 14x plus what would be a perfect square? So I hope you can kind of visualize to get that 14x there. These are both going to have to be 7s. Okay, when I multiply them together, I'm going to get 49. Okay, this one, try it on your own. X squared minus 22x plus, so hopefully you notice this is going to have to be, they're going to both have to be minus 11. Okay, to get them to add up to negative 22. When I multiply them together, I'm going to get 121. Okay, and then this last one's going to be a bit harder. X squared plus 5x plus something. Okay, so now to get the 5, if they're both the same, this time I'm going to have to do x plus 2.5 times x plus 2.5. Okay, and there I get, if I multiply those together, I'm going to get 6.25. Okay, so what I hope you noticed is to get this last term right here, when you're completing the square, you're taking this b value and you're taking half of it, and then you're squaring that. Okay, you're multiplying it by itself. All right. In general, here's a method that you can solve any quadratic equation, anything with. So like we cannot always factor, unfortunately, even though that's nice and easy. But sometimes equations aren't factorable. But you can always solve a quadratic equation by completing the square. In general, your goal is to get a perfect square on one side of the equation and a constant, so just a number, on the other. And then we're going to solve it by taking square root. So we're going to start with a couple more basic ones, and then we're going to get pretty darn challenging. Okay, so if I'm going to solve this by completing the square, what I want to do is look at this left side. And this is actually in the form I want it because I want the constant on the other side. So and I'm going to try to figure out what do I need to add to that to make it a perfect square trinomial. Okay, and I tend to actually write that out. I know it's going to be x squared plus 20x plus something, just like we were just doing. To get that plus 20, it's going to have to be x plus 10 times x plus 10, right? So my last term would have to be plus 100. Okay, but I cannot just arbitrarily add 100 to the left side if I don't add 100 to the right side. So I'm going to go ahead and add 100 to the right side. Then I have x squared plus 20x plus 100 equals 144. Why I like this is because this left side is now a perfect square. This is x plus 10, the quantity squared, equals 144. And I can solve that by taking the square root of both sides. And then I get absolute value of x plus 10 equals 12. Therefore, x plus 10 must equal 12, or x plus 10 could equal negative 12. And then I can solve this. X equals 2, or x equals negative 22. Okay, and hopefully when we check those both, they work. All right, let's look at another one. All right, x squared plus 2x minus 15 equals 0. So your choice, but probably adding 15 to both sides first helps a lot of people. So then you have x squared plus 2x equals 0, and then you can try to figure out like, or not equals 0, equals 15. So let me get that little eraser out and change that. Okay, so equals 15. Then I can figure out plus what is going to be that missing term. So to get x squared plus 2x, I'm going to have to do x plus 1 times x plus 1. When I multiply that out, I'm going to have a plus 1 here. So remember, I can't add it to the left without adding it to the right. Okay, so I've added it to both sides now, and now it looks like x plus 1, the quantity squared, equals 16. Okay, that looks pretty good. I can solve both sides here. So I'm going to take the square root of both sides. I'm going to get the absolute value of x plus 1 equals 4. So x plus 1 equals 4, or x plus 1 equals negative 4. Solve both, so this one's going to be x equals 3, or x equals negative 5. And hopefully they would both work out. All right, let's try another one. X squared plus 4x plus 1 equals 0. This one's going to be more challenging just because of the nature of the numbers. So I'm subtracting 1 first just because that's a strategy and a lot of people like that better. So we can look for our missing term, whatever it would be. Okay, so we know to get that plus 4 it's going to be x plus 2 squared. Okay, and then I'm going to add that extra 2 right there, 2 times 2, so it's going to be a 4. So I'm going to end up having to add 4 to both sides. So now on the left I have x plus 2, the quantity squared, and on the right I have 3. You can see the reason I said this is a little bit harder is because 3 is not a perfect square. So when I take the square root of both sides here, it's not going to look as pretty. So square root of x plus 2 squared, that's the absolute value of x plus 2. The square root of 3, I'm just going to leave that the square root of 3. Okay, because it's not a perfect square, and right now I want to leave it exact. So now I have my two equations that I can write. I could say x plus 2 equals square root of 3, or x plus 2 equals negative square root 3. And then I'm going to solve each of these by subtracting 2 from both sides. And just so you know, it's convention to write that negative 2 first. So you'd probably write x equals negative 2 plus square root 3, or right here, x equals negative 2 minus square root 3. Those would be my two answers. Okay, so I'm not sure if you liked that one, but it was definitely more challenging. Okay, one more, let's try. X squared plus 6x equals negative 34. So I'm going to start off. I have my constant on my right, so I like that. I'm going to try to see what happened here. So this would be x plus 3 times x plus 3. So notice when I multiply that out, that would have had to add a 9 to that side. So I'm going to add 9 to the other side. So now I have x plus 3, the quantity squared, equals negative 25. Okay, and I can take the square root of both sides. I get the absolute value of x plus 3 equals, dun, 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 square root of negative 25. At this stage I cannot do it, so we're going to say no solution. Okay, or we'll probably just write the shortcut. Okay, all right, one more problem. A lot of times you might see the a coefficient not being 1, and generally you want to divide both sides of the equation by a to make completing the square easier. Still not necessarily going to be easy. But so here's a case, 2x squared plus x equals 6. So what I don't like here is that this term's not 1, and it's not a perfect square either. So it might be a good strategy to divide everything by 2 so I get that term to be 1. So then I have x squared plus half x equals 3. Okay, and now to get this to be 0.5, I'm going to have 0.25 each time. I'll just call that 1/4 because I think it's going to be a little easier for me. X plus 1/4 times x plus 1/4. And when I do 1/4 times 1/4, I've added 1/16 to both sides. Okay. All right, I like this a little better because 3 and 1/16, if I write that as an improper fraction, then I get 49 over 16, and that's not too bad of a number to work with because 49 is a perfect square and so 16. Okay, so now I have x plus 1/4 squared equals 49/16. So I'm going to take the square root of both sides, and I get the absolute value of x plus 1/4 equals 7/4. So I know that x plus 1/4 has to equal 7/4, or x plus 1/4 could equal negative 7/4. So if I here it's going to be x equals 6/4, or 3/2, and here x equals negative 8/4, which would be negative 2. And I've got my two answers. All right, I can definitely see we won't have time for the word problem, but I'll throw it out there so that you can at least see it. And we may have to just talk about it in class, but we might have to do like real world problems like this with the area of a soccer field. Completing the square, I think you're going to find it a challenge until we work on it a while, and then hopefully you'll get the hang of it. All right, see you soon.